So basically, what is ACI? ACI is nothing but a simple solution to solve a complex manual configurations. Okay. In a simple understanding, whenever people want to deploy any network in the initial phase, the configuration and the maintaining the standards, each and everything will go smoothly. But over the period, these standards will get diluted. And because of the dilution, the manual errors will occur. And because of the manual error, majority of the team members usually used to stay in the troubleshooting part. So to avoid that, Cisco has adopted its own way of SDN in the data center networking. That is Cisco application centric infrastructure. So it basically adopted. Cisco ACI was not initially developed by the Cisco. It was acquired by the Cisco. Okay. So currently over the past 11 years, the ACI was acquired in 2013. And in the past 11 years, ACI got adopted to many of the industry changes, and it has become the pretty stable one. So that is the reason, even though people want to move with the VMware NSXT also, people will prefer the NSXT as an overlay over the ACI because of its stability. Okay. So ACI is not a purely SDN, but it is a kind of SDN that is adopted by the Cisco. Okay. So what is SDN? So the software defined networking basically has got a few constructs that everybody should follow. So out of that, the openness is one thing that Cisco is missing. For example, if you want to bring the Juniper switches and make it part of the fabric, so that thing is not available with the Cisco ACI. Currently, you have to move with the Cisco EX or FX class switches only if you want to implement the Cisco ACI. Okay. Okay. So what exactly forced the industry to move towards the SDN? So before that, we have to see the history of the compute. So let's move forward. So previously, when the industry was not standardized, each and every company used to have its own network environment. Like IBM has got its own set of protocols, its own set of hardware. HP has got its own, Xerox has got its own, Digital has got its own, and there is no interoperability. Okay. So when it come to the compute, basically for the computers, so if it is following like that, the majority of the manpower, that is the technology brains and the money is getting involved. And at the same time, the outcome or the progress is not much noticeable. So that is the reason initially the standards has been created, like the x86 architecture has been adopted, and the wide variety of manufacturers are basically manufacturing the products. So that's how the components got cheaper, the hardware got cheaper. Once the hardware got cheaper, then the developers kick in and they started developing the multiple applications. That's how the industry got evolved. Okay. So for example, if we see the generation one, there are mainframes, which are mostly from the IBM, proprietary hardware, proprietary operating system applications, and applications cannot be ported across the operating systems, and limited innovation. So currently we are calling it as a limited innovation, but at that time they were doing the innovation with the available resources. But that innovation cannot be applied for another company or another vendor or another OEM products. Okay. So when we move to the generation 2, the hardware was standardized. The PCs were created, and the motherboard basically can be manufactured by any of the vendors. So Mercury, ASRock, or Asus, or any other company who can maintain the particular standards can come and kick in and manufacture the motherboard. And people can get the CPUs from the Intel, and later on the AMD came, or they can get an x86 standard CPUs from any of the available manufacturers, and memory or NIC or keyboard or monitor from the any other vendor. Okay, so basically the standards have been laid, the framework is available, and anyone who can make a product which can fit into that particular framework can basically manufacture the product. So that's how the hardware got cheaper. And then over that hardware, the operating systems were developed, or our existing operating systems got evolved, and they adopted this particular hardware trends. Okay. So some people might have preferred the Linux, some people has preferred the Windows, and there are a lot of application developers came in, and the OEM itself, the Microsoft itself start developing the applications. So that's how the applications has been created, and each and every application is basically meant to solve the some of the people's or some of the organizations requirement. So that's how people understand, okay, if I have got a requirement, definitely I can prefer this hardware and this operating system and this application. This can solve my problem. And tomorrow, if my requirement changes, yes, there are developers available, and based on my requirement, they can develop the applications. Okay, so such a trust has been created with the customers as well as the manufacturers and as well as the managing entities. Okay, so let's move to the generation 3. So in generation 3, basically post 2004 and 2005 era, so we have seen the virtualization. Why? Because if you are using one operating system, and that particular operating system, if you are using a multiple kind of applications, so the manageability is still exists with one operating system. And even though the exponential growth of resources availability is may not be required by the particular operating system itself. For example, if a operating system requires 4 GB, but the particular hardware which is available, if it is offering some 16 GB RAM and probably some 200 or 500 GB of storage, at that time, the hardware is being underutilized. To utilize the hardware to its most, so the virtualization concepts has been evolved by the multiple vendors like VMware ESXi or Citrix or some KVM. So on the existing hardware resources, so multiple VMs can be created, and each and every VM can be allotted to the different teams, so that they can install their own applications and start using the things. For example, a existing hardware can be partitioned, and some of the partition can be available for the app developers. Some of the partitions are available with the DB. Some of the partitions are available with the web developers. So that's how the resources are individually available to the users, and they can develop their own application, and they can particularly deploy the particular application on the existing hardware only without need of purchasing a new hardware. Okay. So in the generation 4 or in the recent generation, so basically the containerization has been kicked in. For example, if you want to deploy an application on a particular operating system, so that application might consume some X resources and the operating system consumes some Y resources. So that ultimately for deploying an application, you require X plus Y. So if you want to deploy two applications, that means it is basically double the resources. It's not like that the existing operating system core cannot be reutilized by the same application. So that is the reason the containerization came in. So that means the container is an isolated space, basically running over an existing operating system, and the same space can be reutilized by using the container orchestration tools like Kubernetes and all. And if an application requires to be scaled out, so based on the requirement, based on the criteria that has been set, the containers can be exponentially grown. And at the same time, the different containers can use the same operating system core, which reduces the hardware resources utilization. Okay. For example, if you take the Book My Show, so if you see the Book My Show, if for example, if you take collectively, if you take the Book My Show resources, and if it is consuming 20% on an average, but if any new movie release during the period, the movie ticket bookings usually hit high. So at the time, what they do, they simply put a scale out rules that if my hardware is reaching, sorry, if my hardware utilization or my container utilization is reaching the 90 or 95%, at the time, the new containers need to be deployed. And at the same time, if the container utilization is going to get down by the 80% or 70%, at that time, the new containers can be destroyed and existing containers can share the load. So along with such a rule in the Kubernetes, so whenever the new bookings or a huge traffic hit on the particular application, the new containers will be automatically created. And as soon as the load went down, the containers will be destroyed. And for creating a container, hardly takes from 2 seconds to 5 seconds. So such a kind of advantages that we can get with the microservices. So why we are talking about the microservices? Because the application policy infrastructure controller, which is being used in the Cisco APIC, is basically has a lot of containers. So not only that, if you take the Cisco SSM, the Smart Software Manager, or nowadays the CCM, the Cisco Call Managers, or you take any SDN application, or you take any SD-WAN, the Viptel or Meraki applications inherently has the containerized applications. That means previously they used to take a Linux code. For example, Cisco usually take the Ubuntu and they basically customized it to such a level they call it as a Cisco Fire Linux. Okay, so they usually take the Cisco Fire Linux and they usually provide one application on that particular Linux. So, but with the with the containerization, what they have done, they have taken the Ubuntu native Ubuntu core, and over that they have simply taken the Kubernetes, and the Kubernetes has been customized, and they call it as the maglev. Okay, so such a kind of developments has been made by the Cisco, not only by Cisco and every other vendor. Currently, we are discussing about the Cisco, so that is the reason I'm giving the example of the Cisco. So such a kind of containerization has been carried out. So that means if you want an application or if you want some code to be developed, so they are simply hosting the code on a container and they are simply importing the container to the particular containerized application. That is either Docker or Docker-D or Kubernetes by using a Kubernetes, the container orchestration tool. Okay. So this is the compute history. So while the compute has been evolved like that over the period, but the network has been rigid for a period. For example, if you take the Cisco, so then previously the available, the old generation catalyst switches, that is 3560 or 3750 or 3550 or 3740 kind of switches which are available in the market due at the 2003 or 2004 period or before that. So basically one hardware has been manufactured and there is a network operating system has been laid, and the particular network operating system can be installed on the particular hardware. So the same hardware cannot be used to install any other application or any other operating system. At the same time, same operating system cannot be installed on any other hardware. That means if you take a 3560 iOS image, the same image cannot be installed on 3750 or 2960 or 2950 kind of hardware. Okay, so for adopting the similar standard, the standards has been laid out in the SDN. So based on that standard, any vendor can come and manufacture his own chipset and can be used by any other vendor. For example, Broadcom Trident 2 is a chipset and largely and widely known as T2 in the industry. And the similar chipset can be imported by Cisco or HP or any other company, and they can manufacture their own switch so that you can use the particular switch in the data center or wherever you require a high speed switching or routing. Okay, so that's how by seeing the compute, the network has adopted the openness. Like if you want to use the VMware NSXT in your data center, you need not to go for a Cisco switch or HP switch or Dell switch. So VMware simply says, when I want to perform the network operation for the data center networking, so that any switch that can offer a delay less than some X value can be used, and any switch which can which uses this particular chipset, the Trident 2 chipset, so can be welcomed and can be used in the data center networking. Okay, basically in SDN there is a controller where we are going to interact with the controller and we are going to make the network rule, or we are going to make the network a policy, and further the controller is going to push the same configuration to the network devices which are available. And at the same time, the controllers are usually based on okay, the controller objects are basically get invoked with the API calls so that the controller can have a north direction. Like you can develop your own API tool and you can create your own workflows so that the user need not to know about the technicality, and simply user can access a workflow and simply put the parameters as the variables, and the similar parameters can be supplied to the API call and the call get invoked to the SDN controller. So that is a northbound communication. And at the same time, once the controller got the input from your tool, similarly the controller can program the logic to the southbound devices which are available. Okay. So this is my SDN controller. So basically, whenever we supply some intent to the SDN controller, in turn the SDN controller will go and implement the similar logic to the particular network devices. Okay. So basically, this is my southbound communication. Okay. So at the same time, the SDN controller comes with its own UI. Okay. So since the UI, for accessing the UI or for programming the particular UI, the one needs to have a particular UI knowledge or a particular logics knowledge. Okay. For example, you got a epic access. Until unless you don't know the constructs which are available in the Cisco epic, you can't configure the Cisco ACI according to your requirement. So usually the businesses has got a standard requirements like provisioning a new service kind of thing. So for the largely available requirements, the workflows can be created. Workflow can be created so that the workflow has got a UI elements, like it's a browser basically with authentication, and some user you have given the privilege, the user can log in. So there is a step one. Okay, he get one page. Okay, web page one. Here he put some inputs. Okay, so for example, if a user wants to create a tenant, so the tenant name or VRF name, such a kind of information can be supplied in this workflow stage one. And stage two, you can supply another information. For example, you want to customize some parameters. So, and for example, if you want to deploy some sort of a route map kind of thing, so such information can be put in the another page. So such a kind of workflows can be created, and in turn, every workflow is linked to an API call and can be sent to the SDN controller. So that means if a operator who doesn't know the epic or who doesn't know the how to operate the SDN controller and want to perform some sort of a network or some sort of a intent related operation on a particular SDN controller, at the time simply the user can access a web page which is designed by the organization and can simply provision a new service. He doesn't need to have the okay, he need not to have the entire knowledge of the networking or any other controller's knowledge. Okay. So that's how this SDN controller helps us to create the or provision the services fastly. So this is basically a northbound communication. So basically, got just a minute. So basically, if you are talking, if the southbound section has got some issues, is it what you meant to say?
Yeah, yeah.
So, okay, if the southbound section has got some issues, for example, if we take the Cisco Epic, so Epic is tightly integrated solution. For example, if Epic is in the healthy state, that means healthy state means among them and as well as the communication with the fabric network devices. So at the time only it will accept the API call. Okay.
Okay.
So that means if there is some issue, okay, for example, if you there is a network device 3, so it's a leaf 3 basically. So on the leaf 3, if you want to provision some service, but somehow the leaf 3 has lost its uplinks, and leaf 3 is basically not reachable to the SDN controller, that is Epic, but you have invoked a call to push the configuration to the leaf 1, leaf 2, and leaf 3 for a new service provisioning. Okay, let's assume it. So at the time, the API call is basically an individual API call for each and every instruction. So the instruction for the leaf 1 and leaf 2 will receive a type 200 message. That is a success message. And for leaf 3, you will get a type 400 or type 500 kind of messages. That is basically a failure message. Okay, exactly. For example,
Okay.
you have got, okay, in Cisco ACI, you have made your total config, okay, complete configuration. You have pushed it to the devices. then you can take out the epics. If you do not want to perform any kind of operation, you can simply take out the epics. Okay, so that means nobody can provision a new service to the network devices.
Okay.
Okay, so SDN may be software defined, but the underlying logic is still routing and switching. Okay,
Yeah.
so there are
Yeah.
two cases. So based on your scenario, I assume two cases. First case is physical links has been lost. Okay, physical links has been lost. If the physical links has been lost, so definitely the underlay ISIS is not going to route any kind of packet. So obviously there is a total outage which is available on that particular leaves. For example, there are endpoints which are available and they are connected to only leaf 3. So on that particular case, that those endpoints will lose the connectivity to the outside world. Okay.
Okay.
But assume that physical connectivity is intact. So that means the routing and switching is still functioning. Okay. But somehow due to some bug or something, the leaf is unable to managed by the SDN controller. On that particular case, the new services will not be provisioned, but the existing services, that means the control plane is still intact on the leaf 3. Okay. So that means for the existing operations, it will carry out. In the ACI topology, just a minute. Let me. So in the ACI topology, it basically follows the class architecture. Okay. Yeah. It follows the class architecture. That means we have the spines. So basically the number of spines that we can have in the network is basically subject to the your deployment requirement. Okay, we have got the leaves. So the golden rule of the class architecture is every leaf will connect to the all available spines. It is recommended. Need not to be followed, but it is recommended. Okay. And from spine to spine and leaf to leaf, there is no connectivity. There will not be. Okay. So one leaf will not get connected to another leaf and one spine will not get connected to another spine. Okay, is it clear?
Okay.
So in this case,
Yeah.
assume that there is a uplink failure. There is a uplink failure case is detected. So since it is a link state routing protocol, it knows the alternate paths to reach that particular leaf. Okay, still the routing and switching logic is still same.
Yeah.
Okay.
Yeah. Understood. Thank you.
So this is the SDN umbrella. So when we are talking about the SDN, so majority of the industry follows the OpFlex protocol. Cisco follows the REST API calls to implement the same. And it is unclear that whether Cisco has implemented the OpenFlow or some other proprietary protocol. Okay, so it has not been documented in any of the Cisco documentations. Okay, clear?
Yeah.
Yep. So what are the planes that are available in the Cisco ACI and what are the topologies that is supported by the Cisco ACI? So if you see the Cisco ACI has got total 3 components. One is the controller and another one is spine. And the last one is the leaf. So controller is the one where we are logging in and providing our logic so that the logic get programmed in the spines and leaves. Okay. And spines are the elements which acts as a backbone or cable aggregator as well as it maintains the COOP database. Okay, and leaves are the devices where we connect our endpoint. Okay, when we are saying the endpoint, it's not only the servers, it can be a load balancer, it can be a WAN optimizer or a firewall, or in fact a router. Each and every device will get connected to the leaves only. For example, there is a leaf, I have connected my leaves, my servers here. So since this particular leaf is accommodating to the servers only, so this leaf is called as the server leaf. Okay. Server leaf, because server leaf is the leaf where the endpoints are only servers, and we are connecting the firewall to another leaf, and as well as the load balancer, and as well as the WAN optimizer. So since is the service oriented devices, this is called as services leaf. And we are connecting the our external links to another leaf. So this is called as border leaf.
Okay.
Assume that you have got a multiple L3 outs, and all L3 outs are flowing via the same leaf only.
Right.
So that means the external routes are basically getting populated in the leaves LPM table, that is local prefix manager table. Okay. So since the leaf 3 is out of network, so that means the leaf 3 may learn and the leaf 3 uplinks are failed. Assume that it is an uplink fail scenario. So the similar information cannot be propagated via MPBGP to all other leaves because its uplinks are failed. We're talking about this failure scenario.
Yeah, that's right.
Okay, so assume that there are total 2 L3 outs are configured. One is red and one is blue. Okay, so both are failed or one uplink is failed?
Only one.
Okay, if one uplink is failed, the corresponding routes received by the particular L3 out, so the red L3 out, the similar information will be withdrawn by using the MPBGP from all other leaves. Whereas the routes which are learned by this particular L3 out, so this information is still available with the all other leaves.
Okay.
Okay.
Yeah, got it. Yes, thanks.
One case total Nexus OS functionality is available with Nexus 9K. Only one thing Nexus 7K that doesn't do is getting integrated with the ACI. That means the ACI overlay part is not available. Otherwise, if you are using the Nexus 9K and Nexus 7K in the NXOS mode, that means the total functionality is still same. Basically, you're talking about the ASIC architecture association with the physical ports.
Yeah, exactly.
So ASIC, ASIC association for the Nexus 7K is different, and ASIC association with the Nexus 9K is different. Okay. So basically, pen is malfunctioning today. Okay. So this is the front panel of the some Nexus 7K or 9K. You take anything. Okay. So there are groups basically.
Yeah.
So there are groups. If you see like 8, 8, 8, 12, 12, like that, there are groups usually used to visible. So, so basically what happens, if you take the Catalyst platform, Cisco Catalyst platform, which is basically designed for the clients, not for the servers. Okay. So there, this particular group usually is managed by one ASIC only. And similarly, the different group is managed by the different ASIC. Okay. So, and if by any chance, if this ASIC fails, only these ports are get affected.
Yeah.
Okay. But in Nexus, since Nexus is a high speed, Nexus is designed for the high speed computing and or high speed network operations. So in Nexus, basically, they maintain it in a bit different. For example, they follow the similar architecture that they follow for the IS XR routers. Okay. For example, there is a group here. This group has got total 4 ports. Sorry, 4 sections. Okay. Each section has got total 2 ports. So that means how they do, basically they get a layer of ASIC here. That means one ASIC manages this group. And the similar ASIC manages this group too. Okay.
Yeah.
Like that. And overall, over that, basically they have one more ASIC, master ASIC, or multiple master ASICs are available to tackle the traffic. Okay, it's basically hierarchical. What I meant to say, it is hierarchical. For example, four groups and all these 8 groups are managed by 4 different level 1 ASICs. And further, there are 2 master ASICs which are available to manage the traffic amount. Okay.
Yeah.
Basically, if your question is related to the VPC creation in the VPC creation for the multiple ports, am I right?
Yeah. Yeah.
So if by chance if it is failed, I don't know how it failed. Ideally, it should not be. Okay. So it is a physical port channel or virtual port channel or multi-chassis, okay, ether channel, or basically it has got some golden rules. That means whenever you are associating any link or any hardware, that is hardware must be same hardware, and the link type must be same. Okay, in ACI, probably you might be thinking, okay, I have got an XS 93108 TC and another 93108 TC, where it has got a 10G or 1G or 100 Mbps capability for each and every downlink port. So why my port channel or virtual port channel has failed? So probably in ACI logical model, we used to associate these ports with a interface policy. So during the interface policy association, the previous policy might be retained on the particular ports. That might cause the issue, or it might be a software bug. Okay, ideally it should not create any problem, because we have done multiple deployments and none of the deployments has been seen such a kind of issues. And yes, at one software version we have seen, let me recollect, I believe it is 4.2, 3 eco or 4 eco, that eco version basically. So in this version we have hit a bug. So it was not allowing us to create such a port channel. So further we have upgraded it to the 4.2 5 series, the 5D or 5G something. So which resolved the issue. Okay. So I suggest you just go through the release notes of the particular software version and see is there any bug available related to that. Okay. Nexus 9K, there is no such a limitation. Only one thing, the interfaces that you are basically making as a member ports for this particular port channel or virtual port channel should have the similar attributes. Okay, like the speed
Understood.
and all. Okay.
Thank you. Yeah, thanks.
Yeah, please. The ACI overview and terminology. So basically, in ACI, there are few logical constructs available and few physical constructs that are available. So currently we will discuss about these constructs. Okay. So in ACI, if you see, there are few terminologies that we come across. That is, one is endpoint. So any server or anything that is connected to the ACI with an IP address is basically classified as an endpoint. And we will club the multiple endpoints together, which share the same policy, that is called as endpoint group. That is called as EPG, the endpoint group. Clear? Okay. So basically, previously we used to refer it as a server or a VM, such a kind of terminology. Here we used to refer each and everything as endpoint only. And we club the endpoints together where the similar policy requirement is there. That is called as endpoint group. Okay, endpoint group is not an automatic. It is basically we decide which endpoint falls into the which endpoint group. Okay, and these endpoint groups are inherently part of the bridge domain. Bridge domain. Basically, bridge domain is collection of subnets. It's like bridge domain holds multiple SVIs. Okay. For example, there is a bridge domain named X is available, and under X, I can create multiple SVIs. That is 10.10.10.1/24, and as well as the 192.168.1.1/24. Like that, multiple subnets can get associated with the bridge domain. Okay. And in turn, the bridge domain is part of the VRF. Okay. In turn, a bridge domain will be part of a VRF, and in turn, multiple VRFs can become a part of a tenant. Clear?
Yeah.
Okay. So this is a ACS logical model. That means the tenant, and under the tenant, there are VRFs, and under the VRFs, there are bridge domains, and under the bridge domain, there are application network profile. So application network profile is a manageable entity which is available. Of course, this application network profile is a name, and it doesn't hold any significant in terms of the packet attributes. For example, if I'm talking about a EPG, that EPG information is part of the VXLAN header, but this application network profile information is not part of anything. For example, same goes with the tenant. For example, if you take the VRF, so how we usually refer the VRF? VRF usually has got a one RD value and one multiple RT values. So by using, we usually do the extra netting. For example, VRF, we provide the RD value, which is locally significant, and we provide the RT value, which we use to import or which we use to export the routes to the other subnets, and which we import basically wherever we want to communicate with that subnets, that particular RT values we use to import the route target values. Okay, so these information are usually part of the network packets. So like that, this tenant information is not part of the network packet. For example, if you create a tenant and if you perform any kind of packet capture, that information will not be visible in any kind of network packet. And same goes with the application network profile. Okay, application network profile. But for creating the EPG, usually we create a application network profile. Under application profile, we create EPGs. Okay, and EPG usually holds the endpoints. Clear? Yep. Is it clear? Is there any doubt?
Yeah,
Yes.
we are following.
Yeah.
Yeah.
You are following. Okay. Thank you. So since it is the logical construct, and we need to move to the physical construct to understand what are the elements which we have to configure to provision such a EPC and all. So initially, what we have, yep, somebody saying something. Okay, so we have to create a VLAN pool where we expect the traffic should enter the ACI domain. For example, if I have a switch here and I'm connecting an endpoint here, it may be a bare metal endpoint or it may be a virtual endpoint. Okay, so if I'm connecting an endpoint here, ultimately on this physical link, what kind of traffic that I'm going to receive? That means am I going to receive the traffic which doesn't has any 82.1q header? That is, it is a simple regular Ethernet frame, or I'm going to receive an Ethernet frame along with the QoS information. That is, it contains some sort of a DSCP value which needs to be treated. Or am I expecting an Ethernet frame with 802.1q header? So based only the type of traffic that we are receiving, so based on that, we will try to create a particular VLAN profile or VLAN pool. Okay. So if you're familiar with the catalyst networking, how you are going to onboard a client PC. For example, you have a client PC and you have connected it to the catalyst on a port number gig 1/0/1. So if this PC, if you go to the network settings and selected the network, okay, if it is a Windows PC, you can go to the device manager and you can select your own LAN card and you can go to the properties, advanced, and go to the .1q or VLAN tag information and you can put a VLAN tag. So the PC will start sending the tagged traffic, okay, or truncated traffic. So if on my particular switch, so basically I usually configure a VLAN. That is, if I'm configuring a VLAN, assume that I'm configuring VLAN 500, which is a IT VLAN. Okay, so this IT VLAN can be configured as a access or trunk, subjected to the incoming traffic. So if I'm configuring it as access port, so I expect a traffic without any tag. If I'm configuring it as a trunk, that means I expect a traffic with the tag. Oh, so the similar approach will be maintained here. For example, this particular port can be made as a part of an EPG, and while associating the particular port to the EPG, I'll associate, okay, this is the VLAN tag that I'm expecting, and the type of traffic is trunk or access. So that means VLAN tag information I have to mention. Why I have to mention? Based on that VLAN tag only, the traffic will be treated, even though it is the similar VLAN tag information is not being replicated as a layer 2. So it will still expect it will attach the tag to be processed. And if I'm making it as a particular trunk port, that means the incoming traffic will be matched against a particular tag. If the tag is getting matched, then only it will accept the traffic. Otherwise, it will discard it. Okay. So basically, whenever you are configuring, okay, what is the VLAN scale? The VLAN scale is 4096. Of course, we can't use total all 4096, probably 4050 kind of VLANs that we can use. So the VLAN scale is 4096. Since it is not a client environment, for example, if you are not offering any services to the your laptops or your desktops, which you use to sit and work, because those are the client and those are client endpoints.
Right.
And the Cisco ACI is designed for the data center where you have got a huge workloads. That means the VLAN information need to be available with the ACI and it should be reutilizable. Okay, it's not only having the VLAN information, and some part of the VLAN information should be reutilized by using a double tagging or some other concept, right? Otherwise, the 4096 VLANs are not sufficient for any kind of data center. Am I right?
Right.
And at the same time, you have a physical endpoints and you have got a virtual endpoints. That means you have got a bare metal servers where you have installed an operating system directly on the bare metal. That means the operating system interacts directly with the hardware, and the operating system interacts with the hypervisor. In turn, the hypervisor interacts with your hardware, the virtual endpoints. Okay, so the endpoints are basically physical endpoints, the bare metal endpoints, and the logical virtual endpoints. Virtual. So the concept of having the domain is basically we have got total 4 domains. That is physical domain and virtual domain and external domain. That is external layer 2 and layer 3. Okay. So the VLAN allocation can be controlled using a static and dynamic methods. Like you can create a VLAN pool X, VLAN pool Y, VLAN pool Z. X I have mentioned the 100 to 200 VLANs are part of the X. Why I am mentioning 300 to 400 are part of the Y, and Z I am saying 500 to 600. And I am making it part of associated with the domain. There I have to mention the allocation. For example, this VLAN information is automatically get ingested into the ACI domain, or this VLAN information is manually to be configured. For example, X I am configured as with the physical domain, where it supports only the static allocation. Okay.
Okay.
And Y I am saying I have integrated a vCenter domain into my ACI, where the EPGs which I am creating are basically getting replicated as a port groups. And since the networking portion of that particular vCenter, the virtual switch, is basically available with a hypervisor administrator, not with the network administrator. So on that case, I cannot start doing the configuration manually. That means, okay, 301 you come on the particular port, 302 you come on the port. Okay, you expect the 301 from the port number 1, 302 from the port number 2, like that. Because since the domain nature is virtual and it has got a multiple uplinks, on any number of port, any number of VLAN can come. So that is the reason we have got the domain concept. Okay, that means if statically I have to accept some VLANs, I will associate it with the particular VLAN pool. And there are some VLANs are being used by my virtual endpoints. There I use a different VLAN pool. So that is the whole concept of having a different domains.
Okay.
And
So basically, yeah.
sorry
Okay.
sorry to
Go
interrupt.
ahead.
And
Go ahead.
one
Sorry.
more advantage is
Mhm.
by misconfiguration of any domain results in service outage. For example, assume that on a virtual side you have configured some VLAN 100. So assume that there is no domain concept, and on the physical side you have associated the same 100 VLANs, and these two are of the different services. Assume that somehow their traffic got mixed, or somehow because of the same domain some storm kind of issues are generated. Ideally it should not be, but such a kind of issues are still the small problems when you compare it with the VLAN information clashing with the external domain, that is with the VLAN tag. For example, if you are using a multiple VRFs at your provider edge router. So for example, you have got a border leaf here. So this border leaf is connected to the particular provider edge router, which is running an MPLS, or you might be running in customer edge environment where you are not running MPLS, still you are running the VP, still you are using the VPNs. So if you have the multiple sub interfaces for different VRFs, so if by any chance this VLAN information get for the physical domain and external domain information got clashed, for example, the services which are being offered via that particular VRF will get impacted. That means the impact scale is higher. So that is the reason they have created a domain concept, and they associated this domain with the VLAN pools. And if a VLAN number is part of one pool, cannot get mixed with the other pool. For example, I'm making a VLAN 100 part of the VLAN pool X. It cannot be made part of the VLAN pool Z. Okay. When you are going for a greenfield deployment, okay. It's basically pertaining to your organization. So ideally, I should not ask. But out of curiosity, just I'm asking, when you are saying a greenfield deployment, for example, you are not having any active servers. The whole fabric has to be laid out. Then you will brought a new endpoints, or you have got an existing network running. You are parallelly building the fabric, and then you are migrating. How you are doing it? That's second option. So that means already you have got an existing network. So in that case, you have to plan carefully. For example, on virtual domain, for example, if you are running the hypervisors, that on hypervisors, how many VLANs that might be needed. For example, if you are planning to keep the ACI in your network for 5 years or 6 years, so you have to understand the scale at that level. Okay, because I have seen an organization which planned very well during the initial stage, but after 2 to 3 years, the servers has gone exponentially and they have moved towards the virtualization and containerization. So the pool that initially they thought for the virtual domain has got messed up. So they have to take they have to use the spare pool which is available in their network. Assume that if they don't have the spare pool, they have to go to the each and every entity, and they have to optimize the pool utilized by the static. Then they have to reduce the physical domain which and the associated VLAN pool. Then they have to increase the dynamic pool which is being used by the virtual domain. Okay, so you need to plan your network accordingly. In the physical model, the domain will get associated with the EPG, and at the same time, the EPG will be associated with a static port, and these static ports are associated with the IPG, that is interface policy group. The EPG information is basically part of the VXLAN only, VXLAN reserved fields only. Okay. So, and one more thing, basically the information which I'm going to tell you is not part of any kind of Cisco documentation. This is based on our interaction with our customers and based on our interaction with the product deployments and all, we came to know that is. So let's take a, let me take a new page. Yeah, okay. It's subjected to where you are capturing the packet. For example, if you capture the packet at the endpoint level, you don't see VLAN information.
Yeah, of course. Yeah.
If it is a trunk port, you will be seeing, but otherwise you'll not. So basically, let's take a traditional architecture, the collapsed care architecture or a 3-tier architecture, that is a core, distribution, and access architecture. So I have my core switch here. I have my core switch here, and I have my distribution switch here, and I have my access switch here. Okay, the core switch, distribution switch, and access switch. On that particular access switch, basically my endpoint is connected. That is my phone or my PC probably. So here I'll configure a VLAN, that is particularly okay, the VLAN 200, and for phone I have configured a VLAN, that is 400 VLAN. Okay. So if you perform a packet capture here or here, are you going to see any kind of tag information there?
No, you will not be.
You will not be. At the same time, if you perform a packet capture here on the trunk port, are you going to see any 802.1q header?
Yeah.
Yes, because whenever we are taking multiple VLAN information and sending it over a trunk port, so that means it is a tagged port where each and every Ethernet frame will be tagged with a 802.1q header, okay, which is of 4 bytes. Okay, so the similar logic is going to apply in the ACI also. So I have my spine switches here. I have my leaf switches here. Okay, so assume that there is an endpoint which is connected. I have configured a VLAN X or VLAN some 400 here. So if I perform a packet capture here, I'm not going to see any kind of VLAN information. And at the same time, if I perform the packet capture here also I'm not going to see any kind of VLAN information. Okay. Previously, we used to see the 802.1q header. So we are able to see the VLAN information, but here it is a VXLAN. The data plane uses the VXLAN information, and this VLAN 400 is referred as a port local VLANs. Okay. In ACI, there is a terminology called as port local VLANs, and there is a terminology called as internal VLANs. Okay, clear?
Yeah.
So how this port local to internal VLAN mapping works? So assume that you have got an EPG. That EPG says all my web servers are part of this EPG. That is called as web EPG. Okay. So in this web EPG, I have associated my physical domain, and in this physical domain, there is a VLAN pool. That VLAN pool is saying from 100 to 200 is part of the VLAN pool. And this VLAN pool X, okay, or VLAN pool web. I'm just giving the VLAN pool web or VLAN pool static. And this static or web VLAN pool got associated with my physical domain. And along with the physical domain, I associate my port here. That means the port Ethernet 1 by 1 is where my server is connected, and I'm expecting a tag of 100, or it is a access or trunk. I configured a VLAN 100 here. Okay.
Yeah.
So since my server is directly connected, I have configured it as an untagged. Okay. So for you, the port local VLAN is basically 100, whereas this particular web EPG is part of web BD, the web bridge domain. Okay. So on this web BD, we associate a subnet. That subnet is 10.10.10.1/24. Okay. So when you log into the Cisco Nexus switch, which is running with an ACI operating system, so it is basically an overlay implemented over the NXOS. So that means a few of the Nexus commands usually you can execute. So, and when you log into the particular leaf, I am just assuming this 1 by 1 port is of leaf 100. Okay, I have logged into the leaf 100, executed the command show IP interface brief, pipe grep, include 10.10.10. Okay, so if I execute this command, usually what I should see, what you expect the output will be. So sorry to interrupt. So I believe the question I was diverted. So in the traditional network, you go to the core switch and execute the similar command. What you will see, VLAN 100, the interface VLAN 100, interface VLAN 100, 10.10.10.1. Status, administrative status up, operational status up. So this is the output usually we get in the Catalyst switches. Am I right? Or in the Nexus switches also, if it is running in an NXOS mode.
Yeah.
In ACI, instead of what we expect, so basically the VLAN information is available and the subnet is 10.10.10.1 only, and administrator is up and operational status up only. But the VLAN number is not 100 here, 100 or whatever the VLAN information that we are adopting here. So that means we are configuring on the particular port is not visible here. Okay. So because this is the port local VLAN and this SVI is associated with the internal VLAN. That means it can be a VLAN 2 also, VLAN 3 also, VLAN 100 also, VLAN 200 also, VLAN 1100 also. Okay. Am I clear?
Yeah, understood.
So the particular port local VLAN is basically mapped to the internal VLAN.
Okay.
The EPG information will be part of the VXLAN reserved header. So if you see any VXLAN standard protocol field, so you will see the flags reserved and VN information and then again flags. So that second reserved field, out of the 24 bits, the 16 bits are used for the EPG.
Understood.
So where we were actually continuing our discussion. So if you see this construct, so this EPG information is part of the header.
Yeah.
And this VN, the virtual network information, is part of the header. Okay.
Yeah. Okay.
No other information is part of the header.
Got it. Yeah. Thank you.
Yep. So previously, whenever we used to provide the services, so we go to the particular interface, and under the interface, we usually provide the configuration. So what kind of configuration that we usually provide? Okay, the speed, duplex, the spanning tree information, CDP, LLDP. So previously on the Nexus or Catalyst switches, the port level configuration that we usually use it to do, the similar configuration is available in the ACI as profiles. For example, if you want to configure a CDP, then you have to go and configure a CDP profile. Then if you want to configure a LLDP profile. And if you want to configure an STP, you have to configure the STP profile. And if you want to configure the speed, then you have to configure the link profile. So everything is configured as a profile in the ACI. And further, you can configure an interface policy group interface policy group. And in this interface policy group, you will call each and every profile. CDP enable profile, LLDP disable profile, STP disable profile, and speed 10G auto profile. Like that, each and every profile can be part of this interface policy group. And further, this interface policy group is associated with the switch profile. That means there is one more profile that get associated, switch profile. So I have configured an individual profiles for each and every individual port level configurations. Then each and every profile will get combined and get created the interface policy group. And this interface policy group in turn part of the switch profile. Why? Because if I have created an interface policy group, this particular group associated to the port number 1 by 1, but that port number 1 by 1 belong to which switch profile? For example, this is for the switch 100 or leaf switch 100 or leaf switch 200 or 300. So that's how this physical model works. If you you have got a X server. So for example, you take the Facebook or Microsoft kind of giants. So they usually do not maintain heterogeneous servers in their environment. For example, they finalize one server. For example, I'll go with a ARM V7 processor and LPDDR4X series RAM and 8 NIC cards and of so-and-so chipset. The network chipset must be same. And like that, they define the standard and they usually custom made their servers. Once those servers are custom made, then they plan the rack. Okay, I have a rack. Then on each and every rack, there will be one top of the rack switch. And for every group of top of the rack switches, there is an end of row switches. Like that, they usually plan. If your data center is planned in such a careful manner, then you can associate a particular switch profile to multiple switches. Okay, that means why I'm saying. So just to let me open a new page. You'll understand better if I do the whiteboard. So so basically, there are multiple racks inside the data center. So this is a rack 1. And this is a rack 2. And you plan to keep a top of the rack switch, that is leaf 100 and leaf 200. Okay. So you have got a server here. And this server, assume that this server is dual homed or quad homed to multiple leaves. And if you are planning to connect this server in such a fashion, for example, here I am using port number 1 by 1. Here also I will use port number 1 by 1 only, no matter what. And each and every port maintains the similar logic. For example, I have got a server 2. This is 1 by 2. And this is 1 by 2. If you have got such a hard-coded rules or hard-coded standards, then definitely you can do that. Okay. Does it answer your question?
Yeah, understood. Yes.
Otherwise, it is in a normal way, it is recommended to maintain one switch and one switch profile. Then multiple IPGs can be reutilized among them.